All right, good morning. It is Wednesday morning, and we are here. Well, you're not here, but I'm not here either. All right, I'm not all here. So, let's get started. Skeletal system notes. Talk about the skeleton. We've been doing that. We've learned all the bones and everything. Now we need to learn a little bit about how the skeleton works and all that kind of stuff and how it all goes together. All right, so let's get down to business. First thing is the skeleton is made of two main parts, okay? Take the skeleton, divide it in two main parts. If we take Mr. Mini Bones here, okay, let me see if I can make this a little bigger so I can see it. There we go. Okay, I can see it. I don't know if that helps you or not. I don't know. But anyhow, if we look at the bone skeleton, we have limbs, things that are attached, arms and legs. And then we have the main part of the body here, okay? All right, the main part of the body is going to be our axis or the axial skeleton. The things that are stuck onto it are called the appendicular skeleton, as in appendixes. Appendix at the end of a book where they stick on things and tell things about it. Well, these are things that have been stuck on. Your appendages, in this case, are your limbs or your arms and legs. All right, so let's look at those definitions a little closer. All right. There we go. Why not coming up? There we go. All right, axial skeleton, all right, is going to be the body trunk, which is the rib cage, the backbone coming down, the sacrum, all the stuff down the middle, all the way down to the coccyx down here at the bottom, up the backbone and the head and the ribs. Okay, all that is the axis or the main center thing, axis of the body. All right. The appendicular, then we said your appendages, which is your arms and your legs, but also it includes the girdle that attaches them to the body, and that would be up here at the shoulder. We have the pectoral girdle, all right, which would be your clavicle going across the front, and your scapula, the backbone, shoulder blade back here in the back. Okay, on your legs, let's just go ahead and scoop this up big enough so you can see it again. All right, so for the arm, it's the arm, the shoulder blade on the back, and the clavicle here in the front. Okay, all right. Now on your leg, it's going to be your leg, and then basically your hip bone on each side, your ilium, your ischium, and your pubic bone on each side. All right, so notice though that the sacrum, which is made out of vertebrae, is part of the axial skeleton. So this is the axial skeleton coming all the way down to the coccyx, but off to the sides here, your hip bones, all that stuff, pubic bone, all that is going to be part of the appendicular skeleton. All right. All right, so next thing after that is, what are the functions of your bones? What do they do for your body? Okay, well, some of the things are fairly obvious, so we'll do those first. Support. Your bones are what hold you upright. Okay, plants don't got no bones, so they have cell walls, and their cell walls hold them rigid. But the bad news is that pretty much holds them still. They can't do much. They can kind of sway in the breeze. That's about it. That's about the maximum movement they can do. All right. We have a skeleton that allows us to be strong and stand upright, but also to be flexible and movable and stuff like that. So that is kind of just the difference between us and them, among other things. Hopefully you have a brain activity. They don't, there's other stuff. We could go on, but you get the idea. All right. Now, the other thing is protection. Okay, support is more they hold you up and allow you not to be a little blubbery mass of soft tissue rolling around on the floor. Okay, but they also protect things. And if you notice, you can kind of tell what's most important to the body by looking at what is protected the most. Okay, the most completely surrounded by bone structure in your body would be your brain. Okay, it's pretty solidly constructed all the way around. It also has cushioning on the inside to help protect it, but it's got bones completely surrounding it. Obviously, your brain is fairly crucial. If your brain is not functioning, you're not functioning. there are two ways that you can be declared dead. One is brain dead, the other is heart dead. Okay, so if your heart quits beating or your brain stops working, then you can officially be declared dead. All right, so got to protect your head. But the other thing is the heart and lungs. Heart and lungs are pretty critical too. If you don't get oxygen and don't get it around to your body, then you're going to die also. So, in your brain will be one of the first things to die if you don't get enough oxygen, just for the record. All right, but it protects all these soft organs in your heart and lungs. You've got the breastbone right in front of your heart, because your heart is, in fact, right here behind your breastbone. We put it off when we pledge allegiance, put our hand over here. Really, technically, we should put our hand right there in the middle. Okay, about nipple high, boom, right there. That's your heart. Okay, right behind your breastbone where it's most protected. Now it's kind of tilted a little bit to one side, and we hear the left side beat harder because it's pumping blood to the whole heart. It's a stronger muscle, but basically, that's how that works. Okay, now. Your heart and lungs are both very critical. Now, notice you don't have much protection down here in your gut, okay? Your belly, all right? And so a lot of times when people in car wrecks and stuff, they have a lot of bruising and damage down there. Is your stomach important? Yes. Is your digestive system important? Yes. But usually they're not going to be as critical to be damaged. The big things are your heart and lungs and your brain. Okay. The other thing is, if we completely protected the whole body, then it would start making it very rigid, and you not be able to bend or move and stuff like that. So you've got to trade off protection sometimes, strength and protection with flexibility. All right. Now, the other thing is, like I said, it allows us to be flexible, so it allows us to have movement. Okay. Now, our bones by themselves cannot help you move. So when you see skeletons jumping around on TV, obviously that's fake news, but in conjunction with your muscles, tendons, and ligaments. We usually say, oh, your muscles and stuff make you move. Well, they do, but if they didn't have anything to attach to and to pull on, kind of use leverage, basically, your arms and legs and so forth are basically levers, and they're pulled on by muscles, and that's what allows them to move in the first place. Okay, so you have many different kind of muscles. You have tendons that attach the muscles to the bone, and you have ligaments that attach bone to other bones. Okay, for example, in your knee, you have the ACL and AML, and there's several other ligaments connecting your kneecap and your various leg bones, tibia, fibia, and femurs and stuff. And so all those things work together to help you to move. Okay, you also have ligaments, for example, that hold your two arm bones together, all right, so that they don't just split off really easy. So they do help us to move. If without them, your muscles would not work. So very important. Now, they're also considered storage facilities. And we don't really think about bones as storing things, but they do store some things that are very important, okay? And so here we go. Number one, when you get old, your bones will have fat storage in the middle of it, okay? All right, even though your bones are very strong, most of them are all hollow, okay, at least the big long bones, like in your arms and your legs and stuff like this. This is a cow's probably femur, all right, and as you can see, there's big empty space inside of it. Now, that can be used to store different stuff. Now, when you're young, baby, pretty young, this is going to be full of red bone marrow. Red bone marrow makes... brain just went dead. Blood cells. But as you get older, it moves up here to the top part, which we'll talk about later. But this part fills up with yellow marrow, which is basically fat. It's kind of fat storage site, place you can store extra energy and stuff like that. Okay, and so that is an important thing for the storage of the bones. If you cut a steak that has a round bone with a hole in the middle of it, before you cook it, it'll be kind of yellowy colored. That's that yellow bone marrow. All right. So fat is stored in the internal cavity of the bone. Okay. So you might want to put that down. I didn't put of the bone, but that's the cavity we're talking about here. Not like your teeth cavities or something like that. That would be silly. All right. Also, calcium ions are needed. Besides calcium, obviously, is a major ingredient in your bone. It's for your nerves to function properly, you have to have calcium ions free. Okay, if you get low on those, then your nerves are going to start malfunctioning and stuff like that. It's also necessary for your muscles to contract. Okay, so for your muscles to contract properly, so the nerves to send the messages, your muscles to contract, you need to have calcium. All right, and it is also necessary for your blood to clot. If you get short on calcium, that can cause clotting problems. Okay, so all those are bad. So where does the calcium come from? Well, the bank, which is your bones. Your bones are like a calcium bank. Okay, and so when you have too much calcium in your blood, it may pull it out and add it to the bones. Okay, and start building extra bone on the outside. If there is not enough, then it can start breaking down some of this bone tissue and releasing calcium back into the blood. So it's kind of like a bank, and your body is constantly making deposits and withdrawals. There we go. All right, and so we're constantly depositing calcium and withdrawing calcium from the bone. So it's putting some in, taking some out, and so it's like having an extra store of it. Now, if you start taking out more than you put in, guess what? Your bones may start getting brittle. As people get older, they tend not to deposit as much calcium, and they tend not to be as active. Exercise helps thicken up your bones, and so they tend to get thinner. And so if you take out more than you put in, just like your bank account down at the bank, you'll get in trouble. All right. Now, the other thing is hematopoiesis. If you look at this word, hema means blood. Poiesis generally means to make. Okay, so anytime we see poiesis, just think to make. So to make blood. So basically, this is blood cell formation. Okay, so all your blood cells are made in your bones. Now, like we said, when you're a kid, you have red bone marrow in the long part of your bones. But as you get older, it kind of migrates, and you can see where there's this what we call spongy bone up here with a little honeycomb looking stuff. Okay, that's about the best place I guess I can show it to you. But and that's where the bone marrow resides, particularly in your femur, but also in some of your flat bones and stuff. And we'll talk more about that later. But basically, it sits up there, and it makes your blood cells. Now, it's red bone marrow, and it makes red blood cells, but also makes white blood cells, which are very important to your immune system and stuff like that. So all these bone cells are made in your bones, which is, I guess, a fairly safe place to put them where nothing will go wrong, I guess. Seems to work. All right. And I can't remember if there's anything else. I think that's the last thing. Yep, that's the last thing. So we will stop right there, and that's it. If you will answer the questions at the end of this recording, and we'll be done for today. We'll see you tomorrow. Same time, same place.